Hello everybody, this is Eben, and today I'm going to talk about indefinite summations. And one symbol I'm going to use a lot throughout the video is obviously the sigma for summation, but also delta. Okay, now delta is defined such that the delta of the summation of f of x is just equal to f of x. And as shown in my video about the generalized theorem of calculus, this is just equal to f of x minus f of x minus 1. So if you have a value f of x and you want to find its indefinite summation, you can come up with random values u. They're actually not random, but they don't have to be anything specific. And you take the delta of u. And you take these values of u and you add them to f of x. And you keep adding as many u's as it takes, well, as many delta u's as it takes, until you get to 0. And then what this shows is that f of x is going to be equal to negative the addition of all these u's. And so on. Now, because of how this works and how summation and the summation work, this is going to be the delta of the addition of all these u's. Because delta f of x plus delta g of x is equal to the delta of f of x plus g of x. Now, what this shows, well, and another thing is, delta of negative f of x is equal to the negative delta of f of x. So that means that f of x equals the delta of the negative value of all of these. And because of this, that means the summation of f of x is equal to these negative u values. So that's how you can find an indefinite summation. So this might not mean much right now, but I'm going to show an example. If f of x is equal to x, and you want to find the indefinite summation of that, you write x down, and you take the integral of it. Now, the integral is the value that'll work out nicely for the following math. So that's 1/2 x squared. Now, right here it has the negative values, but you can avoid this by taking the negative delta, I guess you could call it, which instead of being this, it would be f of x minus 1 minus f of x. So that would make these values all positive if you used this. So we're going to find out if this is f of x, what's f of x minus 1? That would be minus x plus 1/2 by binomial expansion. Because 1/2 x minus 1 squared is equal to this. So then you subtract the original f of x. And I do that by circling. So it's just this. And we're going to add this on, which whenever you add these together, you just get 1/2. So there's a 1/2 left over. And we're going to take the integral of 1/2, which gives you 1/2 x. And then we're going to substitute x minus 1. So you end up with 1/2 x minus 1/2. And then you circle this to show that it's subtracted, and you end with 0. So these were the values of u, which the negative delta was taken of, and it all adds up to 0. So what this shows is that the addition of these u values is equal to the indefinite integral. So that means the indefinite integral of x is equal to 1/2 x squared plus 1/2 x, which are the circled values, which is known to be true. Sometimes it's written as, I believe, x plus 1 times x over 2, but whenever you expand that, it ends up with the polynomial of that. But x is a very simple expression. What about if f of x equals x squared? You write x squared down, and you take the integral. So it's 1/3 x cubed. Then minus x squared plus x minus 1/3. And you circle that, because this whole thing is 1/3 x minus 1 cubed. It ends up just being the original coefficient times that row of Pascal's triangle, because it is just a binomial expansion. And because it's x minus 1, every other term is going to be negative. So you add this all together. And every time you add, since it's the integral, this term will cancel out and you'll always be left with ones after that. So this is what is here. Now we're going to take the first term. The integral of the first term is 1/2 x squared minus x plus 1/2. Circle this to symbolize subtraction, taking it out. And then when you add this together, it's 1/2 minus 1/3, so 1/6. Then the integral of 1/6 is 1/6 x minus 1/6. And you end with 0, just like we said on the opposite side of this page needed to be. So that means that the summation, the indefinite summation of x squared is equal to 1/3 x cubed plus 1/2 x squared plus 1/6 x. And I know it can sometimes be written a different way, but if you expand it, it will come out to this polynomial. And they don't always have to be one term. You could do x cubed plus 1/2 x squared plus 3x minus 5. And you could find the indefinite summation of this with the same method. So that would be 1/4 x to the 4th minus x to the 3rd. Now 6 times 1/4 is 3/2. And then you circle this and add everything together. And you just keep going down until you get to 0, and all the circled values added together will be the indefinite summation.